Hello everyone, John Faulk here with JagSuccess, and today we're going to be covering the topic of completing the square as seen in Precalculus. This is important when working with quadratics. We can do two things by completing the square. We can find the x-intercepts and the vertex of the parabola, all by completing the square. So if we have a parabola such as this, these right here are our x-intercepts, and this point right here is our vertex. So both of these two are very important when learning to graph parabolas. Okay, so let's go over an example of how to actually do this. Okay, so let's say we have an example and we have some function which is x squared plus 6x minus 7. Okay, and we want to know the x-intercepts and the vertex of this parabola. So first, what I like to do is I like to take everything with an x and isolate it in parentheses and leave a little bit of space right here and put the term without the x on the outside of the parentheses. Now, as long as this coefficient here is 1, such as in this one, we take this term right here attached to the x and we divide it by 2, which gives us 3, and then we take this 3 and we square it, which gives us 9. This is going to be a little toolbox that we're going to use. Okay, so we go back and we have x squared plus 6x. Now we take what we get right here, this 9, and we're going to add it and we're going to subtract it. Which seems a little weird at first because 9 minus 9 of course is 0, but that's okay because we're trying to manipulate this function without actually changing it. So next what we're going to do is we're going to take this. We always leave the positive one inside, and we're going to take this negative 9 on the outside. Since we have a coefficient of 1 on the outside here, we just multiplied that negative 9 times 1 and we bring it to the outside, and we still have that negative 7. Alright, so this right here is actually now a perfect square. So we'll always put an x, and then we look back at our toolbox, and since this is positive 3, we'll put plus 3, so we square it. And then negative 9 minus negative 7, or negative 9 minus 7 is negative 16. So now we have rewritten the function in a different manner. So in order to find our x-intercepts, what we'll do is we'll actually just set this equal to 0 and solve for x. So we have x plus 3 squared minus 16 equals 0. Add the 16 to both sides. So we get x plus 3 squared equals 16. Now to get rid of the square, we're going to take the square root of both sides, which this square root and this square goes away. So we have x plus 3 equals, now don't forget when you square root a number, we always get plus or minus, and the square root of 16 is 4. Okay, so now we subtract the 3 from both sides, and we get x equals negative 3 plus or minus 4, which for our x-intercepts, we get negative 3 plus 4, which is 1, and we get negative 3 minus 4, which is negative 7. Okay, so now we have to find our vertex. And the vertex, as long as it is in this form, is quite simple. We take this number here, it's positive 3, and we always take the opposite. So if it's positive 3, we're going to put negative 3. And then for our y-coordinate is always the same. So for this negative 16 is just simply negative 16. So we have our vertex at negative 3 and negative 16, and our x-intercepts are at x equals, let me put this, x equals 1 and x equals negative 7. Okay. So let's go through another example that's a little harder. So let's say we have 2x squared minus 4x minus 2. We do the same thing as last time. Everything with an x, we're going to isolate it in parentheses, leaving a little bit of space, and we just leave the term without the x on the outside. Now this one's a little different. Since we don't have a coefficient of 1, we have to do a little bit of manipulation. So let's just factor out a 2. So if we factor out a 2, we get x squared minus 2x. Okay. So now we can take this term here. Since we have a coefficient of 1 here, take this negative 2. We divide it by 2, always, which gives us negative 1. We take this negative 1 and we square it, which gives us 1. So now we have our toolbox that we will use later on. Okay. So, like before, this 1 here, we're going to put plus and minus. So 2, we have x squared minus 2x plus 1 minus 1 minus 2. And last time, we just took this negative and brought it to the outside, but our coefficient was 1. Now it's 2. So instead what we're going to do is we always leave the positive inside. When we take this negative 1 out, we have to multiply it by the coefficient, which is 2. So instead of negative 1, it's negative 1 times 2, which is negative 2. And then we still have the negative 2 out here. Alright? So now we have 2. Remember, this right here is now a perfect square. And we always have x. We look over here, and this is minus 1. So we just put minus 1. That's squared. Then negative 2 minus 2 is negative 4. And this is just our function rewritten. So to find our x-intercept, what we'll do, let me erase this. We'll just set it equal to 0. So 2x minus 1 squared minus 4 equals 0. So if we add the 4 on both sides, we can divide by 2. 4 divided by 2 is 2. Now we can take the square root of both sides. So now we have x minus 1 equals, and don't forget, this is plus or minus the square root of 2. And we have x equals 1 plus or minus the square root of 2. So our x-intercepts are x equals 1 plus square root of 2 and 1 minus square root of 2. Okay. So now let's look at the vertex. So the coordinates for the vertex will be, remember, if it's in the parentheses, you always take the opposite. So it's positive 1 instead of negative 1. And we always keep this the same, so it's negative 4. So that will be our vertex.